Hey there, and welcome. Today, we're going to dive into the surprisingly complex world of something you probably use every day without even thinking about it, the humble jar lid. You know that sound, right? That super satisfying pop when you crack open a new jar. Yeah, it's a sign that it's fresh for sure. But what you're really hearing is the sound of some brilliant and very precise engineering.
Because that simple twist and pop, well, it's the grand finale of a whole process designed to keep our food safe, fresh, and totally secure. And believe it or not, the story doesn't start with the lid, it starts with the jar itself.
So to really understand the seal, we've got to look at the jar first. Specifically, that very top part of the glass where the lid connects. In the industry, it has a special and kind of old-school name.
It's called the finish, and that name is a throwback to the old days of hand-blown glass, when shaping this rim was literally the finishing touch. Today, it is absolutely the most critical part for getting that perfect seal.
Okay, so here's where it gets really precise. The fit between a lid and a jar comes down to 4 key dimensions. You've got I for the inside diameter, T for the thread diameter, which is measured across the threads, E for the external diameter of the whole thing, and H, which is the height from the very top to its shoulder. Every single one of these has to be perfect. If even one is off by a fraction of a millimeter, the whole seal could fail.
And those dimensions define 2 main kinds of finishes. First is the continuous thread, or CT, which you'd see on a soda bottle. You know, you have to twist it a few times. The other is the lug closure. These are those short, bumpy threads you see on a jam jar that let you open it with just a quick quarter turn.
Right. So the type of finish on the jar dictates the type of lid you can use. And what that lid needs to do, is it holding in pressure or keeping air out? That determines the type of seal. Let's break down the 3 main kinds.
First up, we've got the most straightforward one, the normal seal. This is basically the workhorse for any product that doesn't need a vacuum and isn't under any kind of pressure. Just think about things like peanut butter, dry coffee, or mustard. These products use a simple lid, often with a little foil liner that gets heat-sealed right onto the rim of the jar. It's a really cost-effective way to guarantee freshness for anything that isn't going through some intense heat processing after it's filled. Next up, we have the star of the show, the seal that's responsible for that famous pop. Let's talk about the vacuum seal. The whole idea behind the vacuum seal is actually pretty genius. So, right before the lid goes on, a jet of steam is shot into that empty space at the top of the jar. Then the lid is immediately twisted on. As that trapped steam inside starts to cool down, it condenses, and that creates this powerful vacuum that just sucks the lid down, making an incredibly tight, airtight seal. This vacuum is absolutely essential for preserving foods like pickles and jams for a long time. It actually lets companies pasteurize or sterilize the food right there in the jar. And that pop? Well, that's the sound of the pressure finally equalizing. It's your guarantee that the seal was never broken. And finally, let's look at a seal that's designed to do the exact opposite. It's not about keeping air out, it's all about keeping some serious pressure in. We're talking about your seals for carbonated drinks. You've got the classic metal crown cap or just a simple plastic screw cap. But honestly, the coolest one is the roll-on pilfer-proof, or ROPP. With this, a totally smooth, unthreaded cap is placed on the bottle, and then special rollers actually press against it and form the threads right there on the bottle itself. It's amazing. So, after seeing all this, it's pretty clear that picking a lid isn't just about finding one that fits. It is a really critical decision. The source material we looked at puts it perfectly. The choice of closure is absolutely essential. Get it wrong, and it can literally make or break the product. I mean, picking the wrong lid can be a total disaster. It could cause leaks during processing, jam up the entire production line, or worst of all, just fail to protect the product. And that leads to spoilage and huge safety risks. So the next time you twist open a jar and you hear that pop, you'll know. It's not just a sound. It's the sound of physics, precision engineering, and food science all working together perfectly. What you're hearing is the sound of science.